as we proceed where we stopped. Apologies for what happened, but you know, every time you use free things, they have their own limitation. So I have already uploaded the first recording in the Dropbox, so you can access what we were doing. But I've also started recording this one. As such, if we happen to also not follow it because of other challenges and think, you can also access that one. So without wasting much of your time, because we also have like limited time also, we will need to do more on the time slot that we are given. So I am sharing my screen again and hope you can see. So I have like already uploaded this one, class 2 recording 1. So if you go to your Dropbox, you find the meeting that we just had, the recording of the minutes that we had. So if you go to recording 1, you'll be able to get the recording. Thank you so much. So we were here where I was saying you get to set working directory, you install the package called readx, then you install the package called Haven, and then you import the data from the Excel file called food. And so we felt that we should utilize, I'll just comment these ones also by just putting a hash in the first place, because we already viewed the data. You can also learn the whole of this just by pressing Ctrl-O and then click learn. So it will also learn. As you can see, the ones that are descriptive, the ones that are comments, I will not do anything, we will just pass them. So if we go for descriptive statistics, for example, I choose to understand that everyone knows average. That's my assumption, or what is known as mean. So for example, if there are 10 people and you are asking about age, and then they say, well, I'm 20, someone says I'm 13, and then the other one says I'm 25. We cannot report all of them like in a summary form. We have to come up with one. So we can do average of these and say, okay, out of 10 people that I interviewed, at least the average was 18, meaning to say that was way, most of them, they were around that. That would be a simple way of explaining average. I know there are best other statistical, like mode, median, but those ones we'll be doing as we go. So we want to see our data set, as I said, view data set. Now, how do we get to know the columns of the data set? Like, for example, food. We want to know the columns. So columns, yeah, so columns, like the way headers are in Excel. So if I go to, for example, the very same data set, and then I go to desktop, and then I go to R, and then I go to food, I think I'll be doing it back to back so that at least we can know what I'm talking about. So if I hope you can see my Excel sheet, I open it. So these are the column A up to column J. And here it's group, district name, and the like in the first row. The first row has column names. And then these are what we call observations. Then these are what we call the variables. So here we have a variable called group. We have a variable called district. And then we have a variable called on at least one cow and etc. Now, if you come to here, you just write call and then N like that, it will give you column names. So if you press enter, then column names for food, for example. I run this one, then it will tell me, okay, in the data set called food, these are the variables that you have. You have a variable called group, district name, owns at least one cow, etc. So that's how you know that the data set, the columns that I have in the data set is these ones by using a command called column names. And then I want to know the amount of, what was the average amount of money in savings 2012. So this data was extracted from farmers in somewhere Western Kenya, I understand. And then they administered the questionnaire where they collected the number of acres the farmer had, if they own a solar or not, what was their income in 2012, and how many bags are in storage, and whether they were in treatment group or control group, and then from which district were they from. So we want to just see what was the average, for example, what was the average income in 2012. We have 222 observations. We need just to get an average of that. So how do we do that? If you write sum, then there are a lot of them. So you will pick the summary one. If you pick the summary one, it's just by moving the arrows, you go to and you find a list of sum here, a lot of sums. But for this one, you need just to pick summary. So if I go and then I pick the first one called summary, for example, and then I will summary food. But in order for you to specify the variable, you will need to use a $sign. So in R, once you put a $sign, then a list of variables will come that are contained in a dataset called food. So in this context, I can just scroll down and choose whichever I want. Or if I put $sign, I can reduce them by typing in, then I find income, I pick income. And then I run that one. Then down here, I'll get summary statistics. So for example, the minimum was 6,300 shillings. And this is a first quartile. We will explain as we go, but for the moment, just understand them. Then this is the median for those that understand mathematics and statistics. But for those that don't understand, we will still kind of like explaining as we go with the lessons. And then this is the mean. So the mean here was 8,652. And the maximum was 16,400. So that's how we do the summary statistics. Similarly, we can do summary statistics for WASH, but we need to understand the data. If you click on WASH from the other side, we need to understand the data. So for example, we can get into age respondent. If you click on this one, on WASH, we get age respondent. So we go back to our script, and then we can also write column names for WASH. Learn, then we have a list of them, about 72 of them. We have too many variables, up to 72. And then we can do a summary as well. Summary, but now for what? For WASH, you put a $sign, and then you say age, and then you say age respondent. And if you run that one, it will also give you. So the minimum person was 12, and then the maximum person was 32, which is tricky. You wouldn't find someone up to 32 answering to a questionnaire. So these are what we call like outliers, like data issues. At least I wouldn't expect it, unless otherwise, or else, you know, you cannot find like many of them up to 92, considering the life expectancy. Like this data was obtained in Malawi, the life expectancy in Malawi, you cannot find more up to that particular level. So that's how we do it. And you can also use the table. For example, if you just like tab, and then there will come a table. So if you tab, we want to get a table of WASH, and you put a $sign of their education level, for example. you get education level, and then you run this command. Here it will tell you 0, 113, 1, 256, 2, 123, 3, 5. And here you should know from the background what is 0, what is 1, what is 2, what is 3. So 0, like in the way this was coded, 0 was those that received no education, 1, those that received primary education, 2, those that received secondary education, and 3, those that receive a tertiary education. In a long run, we will be able to like record them back, like put them back, as in to say 0 should be displaying none, 1 primary, 2 secondary, 3 tertiary. But for the meantime, I wanted just to demonstrate how you can do the descriptive statistics. Now, I want to know, out of the respondents, like what is the proportion? For example, what is proportion of people who did not attend any education to all of the people who to all of the people who were sampled, for example, who answered to this question. So I will just write prop, then there comes a table. So proportion of a table. Okay, so if I write wash, I need to still get the same, for example, gender. Sorry, not gender rather, but I want to get to education, so age level. If I do that, it will give me lots and lots and lots of proportions, which doesn't make sense. So what do I do? Here it gives me, it calculates from each, like how many were zeros and the like. So we use the same prop table, but inside here, I will tell it to say, first of all, you need to table wash age level. First of all, you need to table wash age level. Once you have given me a tabular form of that, then get proportion of it. I will remove this, the whole of this chunk. So first of all, you say, okay, I need to get a table of wash, but those that received education, like respondents that responded on the education level. Once I do that, then I need to get proportion. So I'll write from the beginning here, I'll write prop, okay, prop dot table. So dot table, this one will come, and then I'll remove one bracket here, sorry, one bracket here, and then I'll close at the end. So if I run this one, it should give me 18% said they had received no education, and the like. But this is confusing because the numbers are too huge. So what do? I multiply this one by 100 to get at least. So here I would say 18.9, the respondent had no education, 59.7 had primary education, 20.6 had secondary education, only 0.8 had a tertiary education. And then these numbers are too confusing, they are too long. I can round them. So I will put in the first place round, then open bracket, close bracket here at the end. Okay, so I need to round, and look, if I only put one bracket, it will always complain here, and it will tell you why it's complaining. So here it says unmatching open bracket, meaning to say I have this open bracket, but I don't have a closing bracket. So I will put round that one to 2 decimal. I say round the whole of this one into 2 decimal place. So if I run this one, then I'll be able to get 18.96. Or if I change here to 1 decimal place, I run that again, then it will tell you, okay, 19% received none, 59.7 received primary, 20.5 received secondary, and 0.8 received tertiary education. So that's how we do the tabulation. I will show you like complex one, like as we proceed, and how we can format the tables so that they look very nice and things like those, and how we can do the cross tabulation and etc. So that's how we do the like the descriptive statistics. We can do even tabulate like cross tabulation and etc. We have 20 good minutes for this meeting to wrap up. In case someone has questions or I was learning very fast such that you did not understand and you want me to quickly run through these simple codes that I have demonstrated here, then we can always do, you can always come on board and ask those questions. It looks like no one is confused of what I was doing. So, which is in that context, then that's very fine. The last part of today's lesson will be just to view. So we were supposed to import data from Excel. This is what we did. We did not import from CSV. I want you to try on your own. In case you find a problem, you can always let me know. We had to import data from SPSS. This is what we did. If you have a Stata file, you can always try to import that data. Unfortunately, I did not have a SAS file. Then, next, I wanted us also to explore that sometimes when you get data from Excel, most of them will come as characters. So how do we know that this one is a character and how do we know that this one is numeric? I'll demonstrate with the food data. How to tell, okay, I'll comment this one. How to tell the data type. Data type. So you will use a command called class. So if I use class food, $sign will be used so much. Let's get to the districts. So if I do that, it will tell me district is a character. And then I try the same class. I pick class, then food, then $sign. Then now I go to income. And then if I hit income, it will tell me income is numeric. So sometimes the problems that you encounter will be that when you import data from Excel, all of your data set will be in characters. And you are supposed to know how to convert from one data type to another. For example, if it has like imported everything in form of characters, how do you convert from a character to a numeric? And similarly for dates, sometimes if you have a date like 22 December 1991, it also, the format might also not work in R, so you have to reformat it. We will be covering such things in our subsequent lessons on how you can prevent that data input shows only like characters and how you can convert from one data point to the other, on how you can also and then how you can also make dates to be usable. So some of the converters is there, I mean, that we will be covering. you have to convert it. If for you to convert something to numeric, you use as dot numeric. If you want to convert something to factor, for example, gender of a person is male, female, unless otherwise, you can use factor, or you can use a date. Then in terms of descriptive, we will need to understand if there are any outliers, if there is any relationship between the variables. We will also explore much on this and then try to use the graphics. Like as I said, we can do plots like histogram, stem and leaf, and normal. We can use just descriptives such as median, the ones we saw, mean, standard deviation, and etc. Or we can use contingency tables. These are just cross tabulation tables, or like the one we did for was it for gender? Sorry, no, it was for education level rather. Then you can also use the bar plots. We can use the median or contingency tables, or we can do some scatter plots and the like. But I wanted just to let you know that much of your work, what you'll be doing, 80% of your time will be handling the data. So handling the data in this context, I mean that most of your time, almost 80% of your time will be how to get rid of data that you don't need, and how to convert continuous variables into categorical variables. How do you handle missing data? Because you always have missing data. And so you also have to know like operators. I already showed you this slide for last time. I have just changed it the way it looks, but it's pretty the same like what I showed last time, that you can always add, subtract, multiply, divide, or you can get a remainder, or you can get how many times does a number go into something, or you can raise something to the power, for example, 2 to the power 3. But you also need to learn more. We will also be going through and how you can use less than. If you say this A is less than B, for example, greater than or equal to, less than or equal to, greater than or equal to, or something that is not equal to. So for example, we can filter women of reproductive age. So we will specify, remove all women who are less than 15 and more than 45. If we, for example, we have that data set. So we will need to use these kind of operators. Then we also need to understand some logic operators. For example, if we use and what's the difference between and, this and this and, what's the difference between this or and this or, and then this logic operator. So these will be more of our lessons, maybe like in 2 weeks, in manipulating the data using these sort of operators. And then there are other mysterious, like for example, here, there's the one, like the colon one, we also need to understand those. And then if you want to see more of the packages, then you can go to this site. I will just demonstrate, otherwise I'll just demonstrate one here. For example, if you say 1 to 10, so if you do that, you find R will count 1, 2, 3 up to 10. Here you have just written 1, 2, the semicolon 10. So you are telling R that I want you to increment it, create a series of numbers from left operand to right operand. So that's A to B. So that's how we can do more of the analysis in R. But as I said, most of what we'll be covering in the next lesson, almost 80% of our course will be dealing with how can we filter, like how can we create new variables, how can we extrapolate the data, and etc. So this is all what I had for this week, and I will not be sharing more of the slides. We will be capitalizing on these slides to make practical out of it. I mostly don't use the data set that comes with the system. I prefer using the data set that is live. So for example, I used this data set of which maybe I understand, but I would like to invite you to get a data set that you as a person understand that data set, and then try to apply this kind of code that we have written today and see if they are coming out as they were supposed to. So otherwise, our 30 minutes is coming to an end, and if there are any issues, I'm always open. You can say hi on WhatsApp or whatever platform can be used. I'll be able to help. And mostly, I know in the first place it might not look that much interesting, but once we get the data, once we get the gist of it all, we'll be able to do more with this, and you'll be able to write your own code. And I'll also show you, sometimes not like necessary to be writing like every code. There are thousands and thousands and thousands of people that have written online for various codes that we can always copy and then replicate, so long you know what that particular code does. So the famous application for search can be found online. I would want you to try to get to this code Stack Overflow. So Stack Overflow, it has a lot of work, especially on R. So here I can just say how to draw or to what? How to plot a bar plot in R. So if I click that one, I'll get here a lot and a lot and a lot and a lot. So yeah, with answers. So if you get, for example, get on rotating axis labels in R, you find that this one plotted this one, and then this was the code, but it had some problems and people were solving. So for example, this was scored very high, means to say that the person who provided that answer, more like people were supporting that this is the answer. So they are reminding me here that I'm running out of time. I'm only having 9 minutes to go. So we can always like go online, there's Stack Overflow, or just try to Google the same, how to plot a histogram in R. So if you do that, then there are several. So if you click this one, for example, we mostly prefer for those that are like, yeah, so they will demonstrate even here. Okay, so they will demonstrate even here on the histogram, and then you get to like make them look much nicer, and then like that. So you can even try, for example, I'll just try to copy this. Unfortunately, this one would not work because the data set is not like complete here. So we can just try maybe to, yeah, so, okay, so there is a data set called air quality, which has daily, okay, yeah, so we can try to use this one also. And if we go to our R, so yeah, so there's a data set air quality. I'll just call it temp, maybe temperature, just for the sake of demonstration. Then air quality. So I piped it to that. I have added it here. Then I want to do a histogram. So I'll just say hist. I don't know which histogram did they here do. Okay, it's for temperature. So there's a temperature inside, temperature. Let's see what happens. So this one we will need to just get one. I forgot to add one. Which ones do we need? So we need to a temperature of temp, because here I have taken our data set called air quality and I've assigned it to temperature, for example. And then here I want to plot a histogram of temp, because temp is inside the temperature, is like one of the data frame, data variables. So if I do that, then I just learn it, and then you can happily see it from this as far end. And they had to put maybe like change colors and like put for example, here they had to put the topic on top there, the title, and then the x-axis, and then the y-axis. So, and you can find many, and plenty of things online where you can get to run R. And yeah, so that's what's all for today. Unless if any person has questions, I'm happy to answer now before we wrap up. We close as we remaining with 5 minutes. It looks like everyone is fine again. All I am alone. Yeah, John wants to speak.
No, it's okay. That's fine.
Okay, great.
Yeah, it has been so fast. We have captured it, but the good thing is you have recorded everything. So go back to the board and see how we can do about it. And then coming on Sunday, we'll have something, an idea to catch up.
Sure.
If there will be a problem, we'll try to go back. I like this space because maybe with the time we have, the 40 minutes you have been given, if you're not careful, then we will not cover more.
Yeah, that's
So
the other
the
problem.
place we are taking is good. If there is a problem, somebody should ask, and if there is still some problem, then somebody can be able to consult you personally, so that at least they can be able to understand. Otherwise, this is a good place to go, so that you can have a wide range of stuff to learn.
Yeah, to cover. Yeah.
Exactly.
Sure, I'm always available. You can always say hi, or you can post on the group for the benefit of other people.
Exactly, for the benefit of others, for sure.
Yeah, you can post. I was trying this, but it was not working. So how do we do it?
Yeah, are you streaming, no?
Yes.
Okay.
Sure.
That's nice.
All right. So yeah, on that note, that's how we end today's lesson. And just thank you so much for joining, and let's reach out to other people who might also be interested to do this. I know in the first place is always hard, but when you get the skill, I think you can use the skill for many other, because it's not every time you get to have SPSS on your computer. It's not every time you get to have state on your computer for various reasons. So sometimes it's good to utilize these software that don't require you to purchase. Otherwise, buy everyone.
Internal
Bye.
motivation.
Everything.
You can start
You
it.
see, even Ara has many things.
Thank you, Moses. Bye.
All right, bye, Sharika.
Provide us what people, this is very advanced. And the graphs that you put here, if you do a data analysis, use